In problem 1725, we're asked to calculate the free energy change at standard state for this reaction when they give us the solubility product constant. So remember, KSP is for sparingly soluble solids. Iron 2 hydroxide is in an equilibrium with Fe plus 2 ion plus 2 hydroxide ion. And the KSP for that equilibrium is very small, 10 to the minus 14. So the reaction primarily stays right here. Very little goes towards the Fe plus 2 and the 2OH minus side. But we want to calculate the free energy change for this reaction at standard state. So the equation that we're going to use here is the delta G is equal to minus RT natural log of K. Because we're at standard state, we can use K. If we're not at standard state, we have to use reaction quotient Q, but we're at standard state by virtue of the delta G naught. So we'll use K, and the equation for that is delta G. Because we're at equilibrium, we'll use the K minus RT natural log of K. This particular K happens to be KSP. It could be KP like we did in the previous problem. It could be KW. It could be KC. It doesn't matter. K is a K. Products over reactants. Each raised to the stoichiometric coefficient. Minus R is a minus 8.314 joules over mole Kelvin. T at standard state here is 25 degrees, which is 298 Kelvin. And then finally, the KSP given to us in this problem. The KSP given to us in this problem is 1.6 times 10 to the minus 14. For these Ks have no units, so and then we have to take the natural log of that. So natural log of 1.60 times 10 to the minus 14 is that value. So that minus, natural log of this is a minus, we times it by 298, times that by minus 8.314, so it should be a positive at the end. And getting positive 78,703 joules per mole. Now here you definitely want to put the units, right? So the kelvins cancel, and we're left with joules per mole. K has no units. So the answer here is 78,703 joules per mole. Now here you want to put units. You can divide it by 1,000 to get it in kilojoules per mole, which is same thing, 78.7 kilojoules per mole. Okay, one answer is in joules per mole, the other answer is in kilojoules per mole.